Hello, this is Timothy Thrippleton from ETH Zurich. Welcome to the Journal of Ecology video podcast about our paper, Herbaceous Competition and Browsing May Induce Arrested Succession in Central European Forests. In temperate ecosystems, our general perception is that succession typically proceeds to a forested state. Several biotic and disturbance processes, such as herbaceous competition and browsing, can however significantly delay succession. In some cases, these processes can completely prevent tree establishment, which may even lead to the situation where succession is permanently arrested. It is, however, controversially debated whether this phenomenon does occur in temperate zones. The main reason for this controversy is that forest establishment is often a very slow process that can exceed our human time horizon by far. Furthermore, the processes that delay and potentially arrest succession are typically complex and interwoven, which makes it very difficult to disentangle their relative influence. To overcome these restrictions, we use the dynamic vegetation model LandClim that operates on the landscape scale and simulates long-term vegetation dynamics under the influence of various disturbance regimes. The model represents a landscape in the form of a raster of grid cells with specific environmental conditions in each cell. It also simulates the competition between trees and herbs for light and water. Furthermore, tree establishment, growth and mortality are represented. For disturbance processes, we included ungulate browsing, windthrow and timber harvest, which are the three most important disturbance types in Central European forests. We used the model to find out under which conditions arrested succession was most likely to occur. In particular, we addressed the questions: which abiotic, biotic and large-scale disturbance factors are most important, and under which combination of factors is arrested succession most likely. We applied the model to 4 different study landscapes in Central Europe, which cover a large environmental gradient. All simulations were run for 1,000 years under different combinations of factors to test under which conditions succession did not proceed to a forested state. We found that arrested succession was not a common phenomenon, with the exception of the drought-affected study landscape valley, which showed arrested succession in 14% of the simulations. We analyzed the effect of each variable using logistic regression models. Results are displayed as the odds ratio in this graph, with an odds ratio above 1 indicating an increasing probability and values below 1 indicating a decreasing probability of arrested succession. We found that increasing maximum understorey biomass was the most important factor, followed by ungulate browsing. Overstorey disturbances were also important, but to a smaller degree. In terms of environmental conditions, arrested succession became more likely towards south-facing slopes with decreasing soil water holding capacity and towards lower elevations with warmer, drier climates. The combined effect of different factors as simulated in our model is illustrated on this figure for the study landscape valley. The axes of each graph show the amount of herbaceous biomass plotted against the probability of arrested succession. The different rows show different elevations, and the columns show different browsing intensities. The graphs in the top row, which is the high elevation with high precipitation and low temperatures, show overall a very low probability of arrested succession under every combination. This pattern, however, changes as we move towards lower, more drought-prone elevations. In the mid and bottom row, we see that under a combination of high understorey biomass and browsing, arrested succession has a much higher likelihood to occur. To synthesize, our model approach allowed us to address large spatial and temporal scales, and suggests that arrested succession has the potential to occur in temperate zones. Furthermore, it allowed us to disentangle the relative importance of processes and showed that the probability was highest under a combination of high herbaceous biomass and browsing pressure at drought-prone landscape positions.